Okay, so yeah, you can move on next slide. Yeah, in the next one. Okay, so yeah, MTB is just after Etanaf. So our main goal was to find what is a more efficient way of shredding and sorting for the wind blade, and focusing really on the recycling. So as presented by Daniel, Etanaf already focused on repurposing. So what's coming to MTB is wind blade that cannot be repurposed, and only the shredded blades that we need to send for next steps of recycling G's and from Craft or Six. So next slide. What we learn from the first steps of refresh project is like we have a really large blade dimension, and the large blade dimension could be a big issue as we come for shredding, and we start with a movable shredder. This was the first step of the design, and we learned that it will be really hard to accommodate with all type of big blade, and also because a complex composite structure with a large different materials, if we shred all together, it's really hard after to do the sorting. So we go for a cutting blade, so innovative steps from Etanaf that could also sort the carbon and the glass fiber. So we don't mix all together, because it was one of the key points that we cannot pass on for the sorting. Also, the dust emission during shredding is really a big issue, as presented by Jean-Baptiste. We need to avoid the dust for the operator, but also for the environment. So we go for shredding off-site, not on-site, because it will be better for the dust and also the shredding step. So the next slide. The solution we come from with is a prototype and a test of the press shredding equipment. So RSX 2300 from MTB. And what we learn also that the rotor and the blade inside the shredder is really important to get the right size of the material. So we do multiple tests since 2024 to learn what is the best shredding way. So on the next slide. So yeah, this is some of the key figures of the composition when we shred all the materials together, to just show you how much there is heterogeneity inside the materials. And we find a lot of different materials that cannot be sorted. So this is what we learned from the next slide. Yeah, so you can see on the right what we get. So the next slide, you see yes, so there is still a lot of mixing between all the materials, and this is really too difficult to sort them. So next slide, what we come with is to have an intelligent cutting from the field, and we can sort the glass fiber blade and the carbon fiber part also, and the foam and balsa blade. With this sorting on the field and this intelligent cutting, we can go for a press shredding, and sometimes it's not necessary because the blade are at a site that is able for the direct shredding and also the sorting. So we can go for the next slide. Yeah, so this is what we get at the end. So on the left, this is the press shredding and the pre-cutting blade. And at the right, for example, this one is a glass fiber and a wood blade, and we can go for the sorting. So we get the quality of materials required by our partners, so Guilhem Craft and other partners for the next steps of recycling. So the next slide is a summary of what we learn from the sorting and what is the next steps. So what we learn is really we get a good separation from composite, from wood and rigid foam, but we cannot sort glass fiber and carbon fiber, even if we test multiple mechanical dry separation, but also high technology optical sorting. and also a robotized picking solution. And for example, the robotized picking solution, we cannot success in getting a good recovery rate. So the best way is really this intelligent cutting steps before shredding. So that's it from my side.